Hey everyone, and welcome. Today, we're going to jump into one of the biggest ideas in Java, and really in all of programming, inheritance. We're going to skip all the super dense jargon and just focus on the big picture, giving you a really simple, clear way to understand what it is, and more importantly, why it's so incredibly powerful. All right, let's get into it.
So let me just ask you this. Have you ever been coding, maybe working on a couple of different things, and you suddenly realize you're typing the exact same lines of code again? It just feels clunky and inefficient, right? Well, you're definitely not alone. It's a classic problem for developers, and it's the exact problem we're here to solve today.
To really see what I'm talking about, let's look at a super common scenario. We're going to build out a simple example with two classes. Now, on the surface, they seem different, but you'll see they have a lot more in common than you'd think.
Okay, so what's wild here is just how much these two overlap. On the left, you've got a dog class. It has a property, a piece of data like its name, and it has methods, which are just the things it can do, like eat, sleep, and of course, bark. Now look at the cat class on the right. It also has a name, and it also has eat and sleep methods. You see that? That repetition? The code for the name, for eating, for sleeping, it's written twice. Now, imagine if you had 100 different animals. That would be an absolute nightmare to manage. And this is that moment, the one where a good programmer just stops and thinks, okay, there has to be a better way to do this. And the great news is, there absolutely is. There's a core concept in programming that's designed to handle this exact situation, and it's way more intuitive than you might think. All right, so before we dive back into the code to fix this, let's take a quick step back and use a simple real-world analogy. Sometimes the best way to really get a programming concept is to see how it plays out in our everyday lives. I want you to just think about the word vehicle. It's a pretty general term, right? A car is a vehicle. A truck is a vehicle. There are specific examples, but they both fall under that bigger, more general category. And that is a relationship. That's the absolute key to understanding where we're going with this. So because a car and a truck are both vehicles, we just automatically know some things about them, don't we? We don't have to say that a car has wheels or an engine. It gets those things just by being a type of vehicle. It literally inherits all these common features from the main idea of vehicle. And that, right there, brings us to the official term for this whole idea, inheritance. In programming, it's just a mechanism where a new, more specific class, we call it a child, is based on an existing, more general class, which we call the parent. And the best part? The child automatically gets all the properties and methods from that parent for free. So with that vehicle analogy fresh in our minds, let's circle back to our original problem. It's time to take our messy dog and cat classes and clean them up using the awesome power of inheritance. So first things first, we're going to do exactly what we did with the vehicles. What's the general parent category that both a dog and a cat belong to? Well, it's animal, of course. So we're going to create a brand new class called animal, and that's where we'll put all that shared code. Here's exactly how it works. For step 1, we go ahead and create our animal parent class, and we put all the common stuff in there, the name, the eat method, and the sleep method. Then, step 2, we tell our dog class that it inherits from animal, and just like that, it gets all that shared code. And now we only have to add the one thing that's unique to dogs, the bark method. And for step 3, we do the exact same thing for the cat class, just adding its unique meow method. And boom, this is the payoff, right here on the screen. Look at the before. We had code duplicated all over the place, but the after is just so much better. The common code, eat and sleep, now lives in one single place, the animal class. And our dog and cat classes, they're now smaller and way simpler. They only have to worry about what makes them unique. It's clean, it's logical, and it's so much more efficient. Okay, let's zoom out for a second and talk about the big picture here. Why is this idea considered one of the pillars of modern programming? Why does inheritance actually matter so much? If there's one thing to remember, it's this: code reusability. This is, without a doubt, the number one reason to use inheritance. You write that common, shared code one time in the parent class, and then you can reuse it in 10 or 100 or 1,000 child classes. You just write less code, and that means fewer bugs and way faster development. So when you boil it all down, we need inheritance for 3 key reasons. First, to avoid repeating ourselves. It helps us keep our code dry, which stands for don't repeat yourself. Second, it creates this really nice logical structure that often copies how things work in the real world. And third, it makes our code so much easier to manage. I mean, if we need to change how all animals eat, we just change it in one single place, the parent animal class.
Look, if you walk away with just one single thing from this explainer, let it be this idea right here. Inheritance is all about creating these logical parent-child relationships in your code. Once you start seeing your projects in terms of these relationships, a whole new world of clean, organized design just opens right up.
So this whole parent-child thing is super powerful. But it makes you wonder, right? We know the child gets stuff from its parent. But what if that child needs to specifically refer back to its parent? What if our dog class needs to use the original eat method from the animal class before adding its own little twist? How does it do that? Well, in Java, this is handled with a special keyword, super. And that's exactly what we'll be breaking down in our next explainer. Thanks for watching.